In this video, we're going to talk about supplemental examples from 8.3, trigonometric integrals. Our first one is one of the ones I already did in the class notes. This case is when the power of sine is odd and positive. So what we're going to do is we're going to let u be equal to cosine of x. We're going to save an extra sign here. So I'm going to pull one of the signs off over here as sine x dx. I'm going to turn this sine squared x into cosines by turning that into 1 minus cosine squared x times cosine to the fourth x sine x dx. And this is going to be distribute all of this across here. So this is going to be cosine to the fourth x sine x dx minus integral 4 plus 2 is 6. Like that. U is going to be cosine of x. Du is going to be a negative sine x dx. A negative and a negative there. And then bring that negative inside there to make this a negative cosine to the fifth x over 5 plus cosine to the seventh x over 7 plus c. Now, case 1b, number Roman numeral 2 from our 8.3 class notes, power of cosine is odd and positive. So very much the same thing. I'm going to keep a cosine off to the side here. So cosine x dx. And then I have a cosine to the fourth x sine squared x, cosine to the fourth. We're going to make that a cosine squared squared. Cosine squared is 1 minus sine squared squared. And this is going to be 1 minus 2 sine squared x plus sine to the fourth x sine squared x cosine x dx. I'm going to take all of this and distribute it across the parentheses. That's going to be sine squared x cosine x dx minus 2 integral of sine to the fourth x cosine x dx plus integral sine to the sixth x cosine x dx. U is going to be sine x and du is going to be cosine of x dx. So this is going to be sine cubed x over 3 minus 2 sine to the fifth x over 5 plus sine to the seventh x over 7 plus c. All right. Let's look at an extra example of case 1c from 8.3. This is from the textbook here. Powers of sine and cosine are even and non-negative. So we're going to have to use the power reducing formulas. In this case, I'm going to start with the power reducing formula sine squared x is equal to 1 minus cosine of 2x over 2. So I have sine squared squared So 1 minus cosine of 2 times 6 theta is 12 theta over 2. That's d theta. So this is going to be over 4. This is 1 minus 2 cosine of 12 theta plus cosine squared of 12 theta d theta. So let's go ahead and simplify here. This is 1/4 d theta minus 1/2 cosine of 12 theta d theta plus 1/4 cosine squared 12 theta d theta. Now I'm going to have to use the other one. Cosine squared x is equal to 1 plus cosine of 2x over 2. So this right now is 1/4 of theta, and I'm going to do 12, and 1/12 gives me minus 1 over 24 sine of 12 theta plus 1/4 integral of 1 plus cosine of 24 theta over 2 d theta. 1/4 theta minus 1 over 24 sine of 12 theta plus 1/8 d theta plus 1/8 integral cosine of 24 theta d theta. And I'll have a times 24 in here and times a 1 over 24 out here. 1/4 theta minus 1 over 24 sine of 12 theta plus 1/8 theta plus, this is 32, it's 192, I believe. And so this is going to be sine 24 theta. Yep. And then plus c. And that's it. If you want to see the development of those two formulas, I think I have trig videos for them, but let me just start here. Starts with this double angle identity is cosine squared theta minus sine squared theta. And so that would make cosine of 2 theta equal to, replace cosine squared with 1 minus sine squared. Minus sine squared is going to be cosine of 2 theta. Let's go to 1 minus 2 sine squared theta. Switch sides here. 2 sine squared theta is equal to 1 minus cosine of 2 theta. Divide by 2. Sine squared theta is equal to 1 minus cosine of 2 theta over 2. Likewise, I could say cosine of 2 theta is equal to cosine squared theta minus sine squared theta, and replace the sine squared theta with a 1 minus cosine squared theta. Is going to be cosine of 2 theta is equal to cosine squared theta minus 1 plus cosine squared theta. Cosine of 2 theta is 2 cosine squared theta minus 1. And then we're going to say 2 cosine squared theta is equal to cosine of 2 theta plus 1. When I bring this over to this side, I'm swapping sides of the equation though. Cosine squared theta is equal to 1 plus cosine of 2 theta over 2. Just keep them in that order so that all you have to remember is to change the sign. Write the 1 first, minus for sine and plus for cosine, like that, and you'll be in great shape. Okay. Now for case 2a, Roman numeral 2 from the notes here, power of secant is even and positive. So we have secant to the 4th x, tangent cubed x. We want to hold a secant squared x off to the side and let u be equal to tangent here. So let's have the other secant squared turn into tangents. This is going to be secant squared is 1 plus tangent squared. And we've got tangent cubed x secant squared x dx. We're going to take all of that and distribute it here. This is tangent cubed x secant squared x dx plus integral of tangent 5th x secant squared x dx. Turns us into tangent to the 4th x over 4 plus tangent to the 6th x over 6 plus c. And that's it for this video. We'll come back next time and talk about supplemental examples from 8.4. See you for the next video.